This video we're going to do some cell stoichiometry. Cell stoichiometry uses a half reaction, and the half reaction is actually more useful than the net reaction because it tells us the number of electrons required to do this half reaction. So here it says a current of 55 kiloamps passes through a chloralkali cell. What mass of chlorine is formed during 8 hours? So chloralkali cell is going to change chloride ions into chlorine gas. It's got a current of 55 kiloamps for 8 hours. And so with that information, I can calculate the number of moles of electrons because the current times time divided by Faraday's constant is going to give me that value. I'll keep the current in kiloamps because that'll give me kilomole, and it's probably going to save me a step a little bit later on converting again. But I do need my time to be in seconds, and so 8 hours times 3,600 seconds per hour is 28,800 seconds. So I'm going to take that value, and then we divide by Faraday's constant to find the number of moles. So we'll just do that quickly in my calculator, and we find out that we have 16.4. Now, this is going to give me kiloamps, or kilomoles, sorry. So I've got kilomole instead of mole because this is in amps. This is kiloamps, and it's in the numerator. So then I can find the number of moles of chlorine using that value. So I've got 16.4 kilomole. And that's of the electrons. So electrons go in my denominator and chlorine gas goes in the numerator. One chlorine molecule takes 2 electrons. So I need to multiply by 1/2. And so I get 8.21 kilomole of chlorine are produced. So then the mass of chlorine is going to be the number of moles times the molar mass. So 8.21 kilomole times the molar mass of chlorine, which is 70.90 gram per mole, will give me kilograms. So we end up with 582 kilograms of chlorine are produced. And our basic strategy is the same as every Stoich question. We're going to calculate the number of moles of something. We're going to convert it using the mole ratio, and then use it to find another value. This reaction is another cell stoichiometry question. This time they are electroplating silver. So silver ions are becoming silver solid. And they want to plate 10 grams using 1.80 amps. So they want to get that. How long does it take? So what length of time in minutes is required? Well, I know the mass and the molar mass of silver, so I can get the number of moles of silver. It's going to equal the mass over the molar mass. So I get 10.00 grams divided by 107.87 gram per mole. That's the atomic mass of silver. And that leaves me with 0.0927 mole of silver. So the number of moles of electrons, I'm going to take that value, so the chemical amount of silver, and I'm going to multiply it by a fraction. Since that was silver, it goes in my denominator, and electrons go in the numerator. It's a 1-to-1 ratio in this case, so it's going to be the same chemical amount, or the same amount of mole of electrons. But now I'm going to use my number of moles of electrons equals current times time over Faraday's constant to find time. So time equals the number of moles of electrons times Faraday's constant divided by the current. So we get 0.0927 mole times Faraday's constant, 9.65 times 10 to the 4 coulombs per mole of electrons. And I'm going to divide by the current of 1.80 amps. And so we end up finding out that this is going to take 4,969.97 blah, blah, blah seconds. So I need to convert that into minutes because they asked for minutes. So I want minutes, and so I'm going to take seconds here, 60 seconds for 1 minute. So I get 82.8329 on my calculator. I have 4 sig digs and 3 sig digs, so my answer should have 3 sig digs. So it's 82.8 minutes for them to plate that 10 grams of silver using 1.80 amps. So you can see that this is exactly like all our simple Stoich, but now we have to use this Faraday's equation here to be able to sort it out. Hopefully that helps you sort these kind of questions out in the future.